Good morning, everyone. Today we are going to deal with a new concept, that is calculus. Calculus is one of the very interesting and easiest topic in mathematics. So once you get into it and once you start solving the problems, you feel how easy it is. So without wasting much time, let's start today's class. So today we are dealing with calculus. So in the calculus part, first we are going to deal with a concept called as limits. We all know in English, right? What is this limit? Yeah, we say that don't cross your limits, be in your limits and all. So in English means there is a particular level, we should not cross that level, and that is called as limit. So but in mathematics, this limit has a different meaning. So I'll give you a very simple example. Through that example, we can understand what's the importance of this limit is, why it is used and why it is introduced. You just try to solve this very simple example, that is x square minus 1 by x minus 1 at x is equal to 1. So this is a very simple problem, that is x square minus 1 by x minus 1 at x is equal to 1. So if we put the value of x is equal to 1 in this equation, what we will get is we will get 0 by 0. But in mathematics, is 0 by 0 defined? No, right? Then how to solve this value? But I want the value of this function at x is equal to 1. But if I substitute x is equal to 1 in this particular equation, then I'll get 0 by 0. So I can't solve this problem, isn't it? Is there any such problem in mathematics where we don't have a solution for any problem? No, right? Yes. For this type of questions where we actually can't reach the equation at particular values, for example in this case at x is equal to 1, the value of this x square minus 1 by x minus 1 is not defined. So in that kind of situations we are going to use limits. So what we are going to do exactly in this limit is we can't get the value at x is equal to 1. So what we do is we will take the values which are very nearer to x. For example, for this equation, I'll take the values which are nearer to 1. I'll take 0.999, it is nearer to 1, and even I can take 0.9999. So these two values, and even I can take values like 1.0001 and 1.001. Okay, now I took the values like 0.999 and 0.9999, 1.001 and 1.001. Now if I substitute this 0.999 in this equation, that the value I get is 1.999 0, 0. So if I substitute this 0.999 in this equation means the value I get is 1.999 1.9999 and 0. So if I substitute this 1.0001 means the value I get is 2.0001, and if I substitute this 1.001, I'll get the value as 2.0010. So by taking the values which are very closer to 1, we can get the value at x is equal to 1. So I took the values which are less than 1 like 0.99 and 0.999, and also I took the values which are greater than 1, 1.001 and 1.001, which means we can arrive at the value x is equal to 1 both from the right side as well as from the left side by taking the values which are less than 1 and which are nearer to 1, and also by taking the values which are greater than 1 and nearer to 1. So by seeing this answer, we can say that the value at x is equal to 1 lies between 1.9990 and 2.001. So we can say that at x is equal to 1, the value of the function x square minus 1 by x minus 1 is approximately equal to 2. Isn't it? Is it true? Yes. So this is where we will use limits. So limits are used in order to solve the problems in this kind of situations where actually we can't reach the values at that particular point. Like as I told you now, at x is equal to 1 in the first example. I will give another one example in order to understand this limit in a better way. See, consider the function f of x is equal to x square. Okay. Now we want to find the value of f of x at x is equal to 0, but we can't find the value at x is equal to 0 exactly because it is not defined. So we are using the concept of limit. So you can see in this figure, as this x moves towards 0, the function that is f of x, okay, the function f of x also moves towards 0. Isn't it? It also moves towards 0. So we can write that limit of f of x as x tends towards 0 is also equal to 0. So limit of f of x as x moves towards 0 is 0. Got it? So this is one example where we are using limit. So let us see one more example where we'll use this limit, and you will get a better idea of using this limit and why it is used. You are getting right? If you are not getting, let me know. Then I'll explain it again. So this is one more example where g of x is given by, or we can take f of x, g of x, whatever we want. So g of x is given by modulus of x, but it is not defined at x is equal to 0. Okay. So by seeing this function, we can say that as x approaches 0, the g of x is also approaching 0, isn't it? So we can write limit of g of x as x approaches 0 is equal to 0. Okay, you understood the meaning of this, right? As x moving towards the 0, the value of g of x is also moving towards 0. So here, since we can't find the exact value at x is equal to 0, we are taking the approximate values of x which are lesser than 0 and even which are greater than 0, and after performing those calculations, we are coming to the conclusion that the g of x is also moving towards 0 as x moves towards 0. So now you got the little idea of limits. What are these limits and why it is used, isn't it? So I told you in the first example where we found the value of like f of x is equal to x square minus 1 by x minus 1 at x is equal to 1. So I took the values of 1 which are lesser than 1 like 0.999 and 0.9999, and also I took the values which are greater than 1 like 1.0001 and 1.001. So what that means we can approach the value x from both the ways, that is from right hand side even from the left hand side. So this results into two types of limits, that is the right hand limit and the left hand limit. So what is this right hand limit and what is this left hand limit? So let us see with an example. So I'll give you an example. F of x is equal to 1 if x is less than or equal to 0, and it is 2 if x is greater than 0. Okay. Here the first one is this is called as left hand limit and this is called as right hand limit. Okay, what does this right hand limit mean? So in this, the value of x are always taken as greater than a. Okay. In the value f of x is equal to 2 at x is greater than 0. Here the value of f of x is equal to 2 when we take the values of x greater than 0. Okay, 0 means greater than a. So those kind of values are called as right hand limit. Mathematically we can say right hand limit of a function f of x is that value of f of x which is dictated by the values of f of x when x tends to a from the right. Okay, when x tends to a from the right means we are taking the values which are greater than a. Okay, this is an example of right hand limit. So in this case, we can say limit of f of x as x tends to 0 plus, okay, is equal to 2. As I told you, usually we are taking the values which are greater than a, and hence the right hand limit is represented with this plus sign. So limit of f of x as x tends to 0 plus is 2. So in this case we are taking the values of a which are greater than a. Okay, in the first case, as I took 1.01, 1.001, all those values are greater than 1, isn't it? So those are called as right hand limit. So now let us see what is this left hand limit is. So in the left hand limit, we are taking the values of x which are less than or equal to a. So we are taking the values of x which are less than or equal to a. So in the example that we have taken just now, that is f of x is equal to 1 and at x is equal to less than or equal to 0 and x is equal to greater than 0. So in this case, we can take the left hand limit as limit of f of x as x tends to 0 minus. So the left hand limit, we are representing it using minus sign, okay, as x tends to 0 minus is equal to 1. So this is the left hand limit. So we are taking the values of x which are less than a in case of left hand limit. Got it? So mathematically we can say that limit of f of x as x tends to a minus is the expected value of mathematically we can say the left hand limit, or we can write it as limit of f of x as x tends to minus a. This is the mathematical value of f at x is equal to a. Okay, but the values of x are always taken to the left of a, which means the values of x are always less than or equal to a. So this is a left hand limit, and in case of right hand limit, we can say limit of f of x as x tends to a plus is the value of, or the expected value of f at x is equal to a, but the values of x are taken to the right of a and they are always greater than a. So this is left hand limit and this is right hand limit. So now you understood a simple concept called as the limit, and what is left hand limit and what is right hand limit. So next we are going to solve few problems, and if I solve those problems, you will get even more clear idea of limits. Thank you.